Hey 8th graders, so the last Amplify lesson we did was 1.6 where you guys had your little assessment over your modeling tool. Today, since we're starting a new chapter, you guys are going to get a little bit more information from the little space organization as to what happens with the pods and the space station, and then you guys are going to kind of use today to explore that a little bit more and see if we add mass into this, how does that factor into adding forces to an object and having them change direction in some sort or have some different motion that occurs. Okay, so your learning target today, I can describe how objects of different masses move differently after the same strength force is exerted on them. So your very first activity today is to open up your OneNote and add mass to the vocab page of your force and motion section. Mass is the amount of matter that makes up an object. In our next unit, we're going to look at gravity, and you guys will find out how mass is different than weight. Okay, so we actually don't use those terms quite interchangeably in the science world. They are two different things, very similar, but they are different. Okay, so again, mass is the amount of matter that makes up an object. All right, let's move on to our warm-up. Remember that at any point while you guys are watching this at home, you can pause the video, complete a section, and then come back to the video when you guys are ready to move on. Okay? So what you guys have is this little message from Anna Gonzalez at the Space Agency. She says, thank you for sharing your models and explanations. Again, this is what we did in 1.6. This information is very helpful. We analyzed the thruster data from the pod and found that the thrusters exerted the same strength force as any other mission. Since this pod didn't stop, we'll need to look at another cause. The pod had been collecting asteroid samples, and we aren't sure how many it was carrying. Could a difference in the number of asteroid samples explain why the same thruster force caused a different change in velocity? We'd really appreciate your help with this. So obviously in Chapter 1, the main thing we were looking at is how, if we are exerting different strength forces, how does that change the motion of an object? And you guys looked at those two pods. All we really know is that the pod moved away from the space station. So we looked at different strength thruster forces. All right, if we had too much of a thruster force in the opposite direction, the pod would have turned around and moved in the opposite direction. Okay, however, if our thruster force was not as strong as it should be, the pod would keep moving and eventually it would slow down, but eventually it would hit the space station and bounce off and again move in the opposite direction, which is what we know happened. With that being said, we found out that the thrusters were fine. Okay, they fired like they normally did. They exerted the same strength force on that pod like they normally did, but we still know that the space pod turned around and moved in the other direction. So we have to explore some different options. Okay, so in that instance, let's answer this question. Do you think the number of asteroid samples a pod is carrying could make a difference? Okay, think about what that might do to the pod if it has more or less asteroid samples than normal. Might that explain why the same strength thruster force caused this pod to have a different change in velocity? Explain your ideas even if you are unsure. Okay, so again, once you guys are done with your warm-up, go ahead, pause this video, and come back to it when you're ready to move on. All right, just a little background information, really a refresher for you guys before we move on to the little hands-on portion of this. So this is kind of our modeling tool that we use to say, all right, normally the pod comes in, it's moving at a medium speed. The thrusters put a force on that pod that move it in the opposite direction or that exert it on the opposite direction. And that thruster force is usually a medium force, and that causes the pod to stop. Well, we know that that's actually the case as to what happened. It moved it into medium speed. We fired a force on it with the thrusters in the opposite direction. That was also medium, but still our pod kept moving in the opposite direction. So really we're going to be kind of fishing in and figuring out why. Okay? Again, claim 1, the thrusters caused the pod to move in the opposite direction. This is from Chapter 1, where we know it wasn't the thrusters' fault. So if the thrusters on this pod exerted the same strength force as all the other thrusters on the other pods, what else might explain why it moved in the opposite direction? Or if we look at claim number 2 from Chapter 1, the thrusters only slowed the pod down, it didn't stop it. The pod hit the space station, which made it bounce and move in the opposite direction. Well, the pod could have still been slowed down, but it could have bounced off the space station still and moved in the other direction. But if it wasn't the thrusters that exerted the same strength force as the other pods, like what else maybe could have made it crash into the space station that isn't related to thruster force? Okay, so with that being said, in class today what we did is we're going to do a little mini experiment, and what each kid has on their tray is a ping pong ball, a golf ball, and the little thruster, the little launcher that we had. Okay, so what they're going to explore is why might the pod move differently using those objects. So what you guys are going to do at home, since you don't have these materials, is you're just going to think about these things. So how would you test this if you had those materials in front of you? How would you test this? What do you guys think you would see? And what kind of observations would help you draw conclusions about what happened with the space pod? So you guys can still answer these questions hypothetically at home. So how would you guys test this if you had the ping pong ball, the golf ball, and the little launcher? How will you test this example of the space pods to explain 2 reasons why the pods moved in opposite directions if there was nothing wrong with the thrusters? Explain in detail. So tell me how you guys would test this, okay? Since you guys aren't there to actually test it, you guys are just going to tell me what you would expect to see. Okay, you guys can use an example from real life that you guys have experienced before if you need. And then, based on what you learned with this experiment, explain 2 ways why the pod moved away from the space station. So think about those 2 claims, that it turned around and moved in the opposite direction, or that it kept going but slower, hit the space pod and bounced off. So what scenarios would you guys have to explain those 2 occurrences? That it either just turned around and moved in the opposite direction, or that it slowed down, hit the space station, bounced off, and moved in the opposite direction. Okay, once you guys are done with that, we'll go ahead and head on to activity 4. So for activity 4 today, you guys are going to do a little simulation. For this, you guys can see the instructions right here. Here's your sim link, so you guys can right-click that and open it up. Okay, from the Force and Motion Sim, from the menu, select the 2.1 motionless objects, press Run, then press Play to begin. Observe the initial velocity of the objects, then press Prepare Force. To pause the sim while you set up the forces described in your data table. So I'll show you guys your data table here in a second. Use the arrows in the force panel in the bottom right-hand corner of the screen to set up the force on object A. Select object B in the force panel. Use the arrows to set up the force in object B. Repeat for C and D. Press Exert Force to exert the forces and observe how each velocity changes for each object. Press Analyze and then record each object's change in velocity, respond to the questions, and then press Next to continue. So you guys have this data table that's going to kind of help you guys. Your sim looks like this. You guys will go up to the little 3 horizontal lines in the upper left-hand corner and choose 2.1 motionless objects. What's great about this sim is you guys can run it once. All your forces will happen at the same time to all 4 of these objects, and then you guys will be able to collect data 1 time. So you guys don't have to repeat this 4 times. So what we have set up already is we have our object A, which is 0.5 centimeters. You guys can kind of, 0.5 kilograms. You guys can compare the colors to each object. Object B is 1, object C is 2, and object D is 4 kilograms. Okay, you guys can see this all in the data table. Here's object A, B, C, D, 0.5, 1, 2, and 4. So again, these are already set up for you in the data table and in the simulation. Because this is motionless objects, you guys can notice that the initial velocity of all of these is stopped. You guys will also see that when you hit run, and it's already playing when it's in run, I suppose. Okay, so you guys can see that for all of them, as these are motionless objects, so you don't really have to stop them yet. Okay, what you guys are going to do is you're going to prepare a force, and for each of these different objects, you're going to do 4 clicks to the right. So we're going to hit Prepare Force, and we're going to go A right here. Here's the little A tab, 1, 2, 3, 4. There's 4 clicks to the right. Then you'll click on B, 1, 2, 3, 4, 4 clicks to the right. C, 1, 2, 3, 4, 4 clicks to the right. And D, 1, 2, 3, 4. Okay, once you guys have 4 clicks to the right for each of those, you guys can see the pink arrows. You guys will hit Exert Force. Then you'll go to Analyze. When you're in Analyze, remember over here you guys will see this change in velocity. I didn't exert the force, so the change in velocity is not 0. Okay, so make sure you guys hit Exert Force first. I'm not going to do it for you guys because you'll get the data there. So hit Exert Force, let the objects run, observe what happens, and then click Analyze and record your change in velocity for object A, B, C, and D. Okay? Moving back, you guys have a question to answer about that. Use your draw tool. Which object's velocity changed the most? So which had that bigger change of velocity, basically that last column that you guys recorded data for. Okay, once you guys are done with that, you'll move on to the second part of the sim. Very similar to what you guys did, except you guys are going to choose a different sim. We're going to go to moving objects. So as you guys see at this, each of these objects are going to start out moving, and we're going to see what happens to their change in motion here. So again, select moving objects, run it. Right when you guys run it, you're going to have to pause it and hit prepare force. So we'll hit run, and then we'll hit prepare force. So that'll stop you guys. So see, they're all moving to the left. They're all moving to the left with a velocity, if we look in our table, of 2 centimeters per second. Okay? You can see we have the same masses as the last time. And just like we did before, we're going to do 4 clicks to the right. So when we hit prepare forces, A, 1, 2, 3, 4, B, 1, 2, 3, 4, C, 1, 2, 3, 4, and D, 1, 2, 3, 4. So they're moving to the left when we start. We're going to prepare a force that moves them in the, a force in the opposite direction. So we're going to see how their velocity changes. They will not all respond the same. So keep that in mind. Once you guys have your 4 forces prepared for each object, 4 clicks to the right, you guys will again click exert force and then hit analyze, and you guys will record the change in velocity in this right hand column. Okay? And answer this question: which object's velocity changed the most? A, B, C, or D? Okay? Using what you guys know or learned from those 2 sims, okay, your goal for the next part of this sim is to make the fastest object in the sim that you can. So you're looking for the largest change in velocity. Okay? Exert a force only one time. You guys can start with a motionless object. You can start with an object in motion. That's really up to you. Again, you saw what happened to all those pucks in the other 2 parts to the sim. So use that knowledge to help you guys figure out 3 different tests. You guys basically have 3 tries to find the fastest object. So conduct 3 different experiments. Choose different masses. Tell me what you used. Tell me the size of the force you exerted. You only get to exert 1 force, but you guys can choose the size of that force. That's up to you. Okay? And finally, the direction of the force exerted. What direction did you put it in? What was your initial velocity? And after you guys run that, what was your change in velocity? Once you guys have 3 trials done, you're going to use your draw tool to circle or highlight the best of your 3 choices. Okay, so you guys will do that directly in your table. Okay? Once you have finished that, we can go ahead and move on to the last part, which is today's homework. Here you guys have an article to read called Designing Wheelchairs, so right-click and open that link. It's going to take you guys into this article and amplify. So go ahead, read and or listen to that article. Remember, you guys can listen by clicking the speaker and hitting play. And then answer these questions. Use your draw tool for which wheelchair would be more difficult to stop, the more massive or the less massive. If the same force were exerted on both wheelchairs, which wheelchair would go faster, the more massive or the less massive? And finally, how would you design a wheelchair for a wheelchair using basketball players? So someone who plays basketball from a wheelchair. Would you make it more or less massive, and explain how? So what did you guys learn from that article that would explain why you guys would choose a more or less massive wheelchair? Okay? Once you guys are all done, go ahead, do your wrap up. Do you have any questions? Circle yes or no. If you have questions, type them in right here, and then 4, 3, 2, 1, how do you think you did? Go ahead and hand it in, and I hope you guys are having a great day. Bye.